Okay, here we go. Chapter 10, test review. Mo, stay with it. Here we go. Chapter 10, test review. Um, of course, we will have double angle and half angle formulas. And we'll use those to find sines and cosines and tangents. Things like sine of, I don't know, 75 degrees. What would you use that? How would you use that? If you were, if I were going to say find the sine of 75 degrees, and I'll say without a calculator, or I'll say something like, um, give simplest radical form, which forces you to not use a calculator. 45 and 30, 45 plus 30, or sine of 105 minus 30. Either one of those will work, and they'll work just fine. But be able to use those. It's not a matter of memorizing anything. You can write them all in your notes, all those little tables they had in the book. Just make sure you have those in your notes, okay? Because otherwise you're going to be hurting big time. Questions on that part? Um, I'll have some simplifications, some nasty, ugly simplify things like 1 plus cotangent squared theta times cosine 2 theta plus 1 or something like that, where you just have to clean it up, and all of them clean up nicely. You don't have to worry about that. Um, gonna have definitely those. Some exact value ones for things like this. Um, some definitely you'll have to use the Pythagorean identity, which is what? Pythagorean identity, sine theta squared plus cosine theta squared equals 1 squared. And normally you see that written as sine squared theta plus cosine squared theta equals 1. You'll definitely have to use that. Used in many, many, many ways. I'll probably throw in one of those like we talked about the other day, where it says find the two supplementary angles formed by, 3x plus 4y equals 12, and, 5x minus 6y equals, whatever. I'll give you two lines, they intersect. Anytime two lines or line segments intersect, they're going to form a couple of supplementary angles. And they'll say find those angles. And whatever answer you get here, they have to add up to how many? 180. That's what supplementary means. They're they're also called linear pairs or straight angle theorem. You hear all those terms. They just whatever answer you get, they have to add up to 180. Mo. Yes. Oh, great question. This angle here, they're called vertical angles because they share the same vertex and they are congruent. It's a great question. That's from way back when. Nicely done. I'm glad all those brain cells are still intact, Mo. Clean and sober. That's what it is. Right. Okay. What else? Um, put that on there. Just be able to deal with radicals. I'm going to ask for things in simplest radical form and be able to handle that. You know, if I say the tangent of, I don't know, give me something easy. Tangent of 60 degrees. Well, that equals the sine of 60 degrees over the cosine of 60 degrees equals what? Square root of 3 over 2 over cosine of 60 degrees. He's probably wrong. Someone else. No fun at all. Over 1/2. And at this point, what do I have to do? Multiply numerator and denominator by 2. Okay? And when we're all said and done, what do we have here? Just square root of 3. Right. And all of that without a calculator, and that's just dandy. So be able to deal with radicals. Be bilingual. It's cooler. Okay? I multiplied the denominator and numerator by 2 over 1. The reciprocal. Reciprocal. Be comfortable with that term. No? Well, it's because you had such a good geometry teacher way back when. Okay, let's keep going. Um, there was one other thing I was going to talk about, and now I kind of lost it. Oh, I had it, and then I lost it. Oh, I was going to talk about Derek, regroup. Alex, be a good influence. I was going to remind you all about ratios versus, I don't know, functions. Okay, if we're dealing with, and I'll start with a right triangle because it's more straightforward. If we're dealing with this angle, which, I don't know, 30 degrees here, and this is 1, then what's this length here? Yeah, 1/2. And what's this length here? Good. Because we say the cosine of 30 degrees is the length of the adjacent side divided by the length of the hypotenuse. In this case, it's just 1, so it's square root of 3 over 2. And it's important to think of these, Alex, as ratios. Okay? Because some people are getting mixed up. I have people doing this stuff. Cosine of the square root of 3 over 2 equals 30 degrees. Is that true? Ick. All I can say is ick. Okay? This is a ratio. This is an angle. Okay? You cannot use cosine function or sine function or tangent function on ratios. I mean, you can. You can punch it out in your calculator, Chad, and it'll give you an answer, and you'll go, you know, as the drool dribbles down your chin. It must be right, dude. calculator told me so. You know, and that's not cool. Chat. Well, no, the concept of sine, cosine, and tangent, right angle trig works for any right angle triangle. Okay? These ones are just nice. They come out evenly, but it works for any right angle triangle. Well, some are approximations or really, really big fractions. Some are decimal approximations for sure. Um, I use the 30, 60, 90, the 45, 45, 90, because those come out so nicely on our unit circle. Okay? But it works for any right triangle. And that's a really good question. It doesn't work for non-right triangles. When we have non-right triangles, what do we have to use, Alex? Non-right triangles, what tools do we have? And you bet. Good. So in those cases, you can use law of cosines, law of sines. Okay? I mean, you can use law of cosines, law of sines for anything, but it's easier just to use straight right angle trig for these, sine, cosine, tangent, and law of sines, law of cosines for the non-right triangles. Good question, Chad. Thank you. Okay, but please, please, please don't mix up ratios and angles. Okay, and that gets even more complicated when we start doing this stuff. When we start going, oh no, it's no longer 30 degrees, it's pi over 6, you know, gasp. And then, you know, they start to look the same. Okay, but just remember, use cosine, sine, tan function on angles. Use arc cosine, arc sine, and arc tan on ratios. Okay? Because a lot of people are still not getting that. You know, I'm going through checking those chapter 9 tests, and people are getting them mixed up. The tangent of, I don't know, give me a weird angle. 80 degrees equals what? What's the tangent of 80 degrees? Well, no, you can just take your calculator and give me that. Yeah, I don't care. Okay, then go arctan second answer equals 80 degrees, right? Okay. And that's easy for 80 degrees, but what about when you go, you know, the tangent of, I don't know, I'll just think of something. 1.5 radians. Okay, put it in radian mode. In radian mode, Jackie. What's it say again, please? Yeah, equals 14.1. Now these things are starting to look weird. Like which one's the ratio? Which one's the angle? This one's the ratio. This one's the angle. Angle in radians. Okay, and it starts to get a little weird. And then you go arctan. I need to go back to red. Then you go arctan, you know, 14.1, and you get approximately 1.5 radians. So just be careful with those, is all I'm saying. Make sure you always know which one's an angle, which one's a ratio. That's important. It's about, being in control of your own life and not believing what people tell you to do. Gosh. Man, it's crazy out there. Okay, questions. All right, gonna call it good. Thank you, those at home, for listening. That's like you, Olivia. Who else is gone today? Tennis. Olivia and Nick, who's not here. Thank you, Nick. Um, and who else? Aaron, Matthews, tennis. So good luck. And Anna Gatherum, the ghost of Anna Gatherum. Good luck.